Hello y'all, we are Memphis Communiversity and today we are doing another calculus done wrong lesson where we wrong calculus before calculus wrongs us. And today what we're going to be doing is we're going to continue our derivative taking journey. We're going to try to become derivative masters, of course. So today is a very important day. What we're going to be doing is a 2-in-1 special. We are going to be learning the product rule and the quotient rule and how to apply them. So as you take more and more derivatives for the next few months in your calculus class or maybe for the rest of your life, you'll encounter having to take derivatives of products and quotients. So these two rules are very important. As the name implies, you might assume that the derivative of products is used by the product rule. And if you have a function that's a quotient, how do you take that derivative? We're going to be using the quotient rule. So they're pretty aptly named, of course. Because this is a calculus done wrong lesson, we aren't going to prove the product rule and the quotient rule. That's probably teaching calculus correctly. What I want to do today is I just want to focus on both of the rules and just provide examples. So let's get started. Let's talk about the product rule and the quotient rule. Two of my very good friends never have wronged me in the past. Let's just see what happens. So let's first list the product rule. So again, what the product rule is for is to take derivatives of products. So you're going to have two functions, f and g. So these are two functions, and we want to take its derivative. Some teachers teach it differently, but what I do is I take the derivative of one of the functions, and it doesn't matter which one you choose, the first one or the second one. Let's just say we take the derivative of the first one. So we're going to write f prime. Then what you do is you keep the same the function you didn't take the derivative of. So we have two functions here. Because we took the derivative of f prime, what we're going to do is we are going to keep g the same. So we're going to write times g. So its derivative, keep the same. This is just one half of the product rule. Ironically, the product rule involves a sum, so let's write that plus. For the second half of the product rule, you do the same thing, but you just switch the roles. So because we took the derivative of the first function, in the second half of the product rule, we're going to take the derivative of the second function. So we're going to write g prime instead. And then finally, because we kept g the same in the first half of the product rule, we're going to keep f the same in the second half of the product rule. So it's going to be f g prime. So some people remember it as derivative of the first, keep the second the same, plus keep the first the same, derivative of the second. Or derivative of one, keep the other one the same, keep the first one the same, derivative of one. And because addition is commutative, of course, you can switch this around. So again, I do the product rule in different orders depending on what the function is, as we'll see. But you'll see that you'll get used to it, and it doesn't really matter which way you do it. Just derivative, keep the same, derivative, separated by a plus. So it's not going to be too bad. Now what we're going to do is we're going to talk about the quotient rule. So this is the quotient rule. Again, we're going to do two rules at once. I believe that we will be capable of doing this. So what's the quotient rule say? Well, the quotient rule says that if you have a function that's a quotient, so it's going to be, instead of f times g, it's going to be f over g, and you want to take this derivative, you're going to use this rhyme that I'm about to say. I think everybody in the world says this rhyme as they do and apply the quotient rule. So it's going to be low, which refers to g. Let's actually write the words low. So it's going to be low. And when I say low, and I'm about to say the word high as well, that means the denominator will be low and the numerator will be high. So the rhyme is low d high, so low d high minus high d low over low low. And again, everybody says this rhyme. This is a rhyme because low rhymes with low, of course. Low d high minus high d low over low low. So as I'm going to be taking the derivative of these quotient rule questions throughout this video, I'm going to be saying this rhyme a lot. Low d high minus high d low over low low. Why don't you say this and I'll wait 2 seconds awkwardly. Cool. So it's low d high minus high d low over low low. Just say that over and over and over and over and over and over and over again, and you should be good to go. Keep in mind that it's minus here and also that it's low squared. If you want to write it with f's and g's, then this would be, well, low would be g, so it'd be low. When I say d high, obviously, I mean the derivative of high. I probably should have mentioned that. When I say d low, I mean the derivative of low. So it's low, derivative of the high, derivative of the numerator, minus the numerator itself, the high, times the derivative of the denominator, which is d low. With f's and g's, it'd be low, which is g, then d high would be f prime, minus high, so that's f, d low, which is g prime, and then just don't forget low low. A fairly common mistake because you get so excited to do low d high minus high d low that you might forget low low. But these are the product rule and the quotient rules. So product rule again, the derivative of product, derivative of 1, keep the same, plus keep the same derivative, and then quotient rule is low d high minus high d low over low low. So let's see this in action. You'll probably understand it better if this is your first time doing the product rule and quotient rule. Don't get worried. Eventually you will be a seasoned veteran. Let's try some examples. Let's maybe do 10 examples because these questions are fairly quick. If you haven't watched our previous derivative videos, you probably want to watch those first because they will include examples. Those two videos were the power rule video, for which we're going to be doing a lot of power rule stuff because it's going to be one of the parts of the product or the quotient. Also, if you don't know the trig derivatives, we're going to mention those, so watch our previous videos if you want help with that. Let's just see our first example. So my first example is going to be y is equal to, let's do x cubed times sine x. So this is going to be my first instance of the product rule because I have a product on my hands. So let's, for the first few, I'm going to do is I'm going to underline things. I like to underline the two halves of the question, the two parts of the product, in order to better and more easily employ the power, or not the power, or the product rule. So I'm going to underline this, and I'm going to underline this. So this is the power rule. Remember what you do is you keep the same, derivative plus derivative keep the same. So let's just write y prime, and let's get on to it. So what you do is you just choose to take the derivative of one of them. It doesn't matter which one you do, you just have to switch it in the second half. So for this one, what I'm going to do is I'm going to take the derivative of x cubed. That is the power rule. Remember that you drop the power to the front, so it's 3x, and then you subtract 1 from the exponent squared. And then this is the first part of the product rule. I took a derivative. Because I took the derivative of the first function, I'm going to keep the same of the second function, so I'm literally just rewriting it again. So that's sine x. So this would the derivative of the first, keep the second the same. And then remember that the two halves of the product rule is separated by a plus. So because we took the derivative of the x cubed in the first step, in the first half of the product rule, for the second half of the product rule, we're going to keep the first guy the same. So we're just going to literally write x cubed. And then finally, we're going to take the derivative of sine of x. That is going to be cosine x. That's something I memorized a long time ago. But again, this is the product rule. So how exciting. It's derivative of 1, keep the same, plus keep the same times the derivative. And that's all it is. So you could have written this one first. You could have kept the same derivative and then keep the same derivative because again, you can switch this around. So that's just the product rule. As long as you start practicing these, you'll probably master this product rule. As long as you can recognize, oh, I have to do the product rule, as opposed to maybe writing just 3x squared times cosine x, you should be good to go. So let's do the quotient rule now. One example of the quotient rule, and then another one, and then another one, and then another one, until we get sick of it. But we're never going to get sick of it because it's the quotient rule, and we love the quotient rule. So let's see here. What do we want? What if we do y is equal to x to the 7th on the top, and then we're going to have, let's take, let's see, what do I want? Let's take tangent x. So we're going to take this derivative. Again, obviously we have a quotient rule example here because we have a quotient here. When we do the rhyme, low d high minus high d low over low low, low refers to the denominator, that's going to be tangent x in this case. High refers to the numerator, that's going to be x to the 7th. Keep in mind that I say the rhyme out loud, or at least in my head, as I do the question. So let's try that. Let's see that in action. So y prime. So it's low d high. So low refers to just rewriting the low or the denominator. In this case, it's 10. So this is the low part. So if you want, this is low. Then d high, that refers to taking the derivative of the numerator. That's the power rule again. Take the 7, drop it to the front, and then subtract 1 from the old exponent to form the new exponent. So that's going to be 7x to the 6. This was the d high part. And then it's going to be minus high. High is pretty easy because there's no d in front. So all you have to do is just rewrite it. So that's x to the 7th. So low d high minus high. And then we want d low at the end. How do you take the derivative of d low? You just know the derivative of tangent x, that's going to be secant squared. Nice to know your trig derivatives. Just keep practicing with index cards to make sure that you know them and they're sort of seared into your brains. Finally, at the very end, it's pretty easy. Just don't forget low d high minus high d low over low. So in this case, what we're going to do is we're going to divide by tangent x squared, and we are done. So this is the quotient rule. Low d high, taking a derivative, minus high d low, taking the derivative of the denominator now, over low. So that's that. Now let's just do example after example after example after example so that we can practice our derivatives, we can practice the product rule, we can practice the quotient rule. So I'm excited. Let's keep going. Nobody can stop us. Let's get going. So let's see, what do we want here? Let's do y is equal to ln x times square root of x. So this is another example, of course, of the product rule, because I have something times something. Remember in our power rule video, we love the power rule so much because we want to use it as much as possible because it's easy. So what we want to do is we want to change certain questions to be the power rule. So what I'm going to do here is before I take the derivative, often an easy step is to change this to a power so that we can use the power rule. What is square root of x? That's going to be x to the 1/2. So this is going to be my two things. Let's go for the product rule now. So it's going to be the derivative of one of them. Let's just take the derivative of ln of x first, 1 over x. Then you can keep the next one the same. So it's first derivative of the second. So that's again the power rule. Drop that 1/2 nicely into the front, 1/2. And then what's the new power? That's 1/2 minus 1. That's the same thing as 1/2 minus 2/2, of course. So that's negative 1/2. How lovely. Then keep in mind that we've only done half of the product rule, but we're going to finish it off. What we're going to do is we are going, oh, I did not do the power rule here, right. Notice that I made my mistake here. So hopefully you can recognize what mistake I made here. What I did is I took the derivative of one and the derivative of the second because I have no idea what I'm doing. But let's try to change this to the right thing. Sorry about that. So it's the derivative of one, the derivative of ln of x. What I needed to do is I needed to keep the first function the same. So I didn't do that, but let's keep the first function the same. So you can either write it square root of x or x to the 1/2. So this is the real product rule. Oftentimes you'll make mistakes taking derivatives, but sometimes mistakes are just part of the fun. So again, this is derivative, keep the same, plus, so this is the plus that separates the halves of the product rule, and then you have keep the same ln x, because we took the derivative of that one in the first half of the product rule, so we're going to keep it the same, ln x. And then this is where we multiply by that 1/2 x to the negative 1/2 that I wrote earlier by mistake, because this is when we're taking the derivative of this guy right here. So again, it's derivative, keep the same, derivative. F prime here, if you were using F primes and G's, if this was F and G, F prime G, F G prime. So it's not that bad. Just take the derivative of one, keep the other one the same, plus take the derivative of the one you didn't take the derivative of, and then keep the other one the same. So that's all it is. If you want, of course, if this is a multiple choice question, I don't know about your teacher, they might ask you to simplify more, but this is just the unsimplified form. This is potentially simplifiable because you have x to the x, so I'm going to just simplify that one just to see if I can do any math anymore because I missed the product rule earlier. When you have the square root of x over x, that's just 1 over the square root of x. And then you really can't simplify this. We can still write it as the square root of x. And then we can have ln x on the bottom here. So that's what I'm doing. I'm just changing this back to a square root. And it's also in the denominator. But this is not part of the product rule. You can obviously combine these guys as well. But this is just sort of the answer. So hopefully this makes sense as a product rule example. Let me see if I can redeem myself with a quotient rule example where I don't mess up. So again, nice little product rule example. I'm going to erase this guy now. So I think that's 3 examples. Let's try to do 10. So let's keep going. Let's do another quotient rule. So it's going to be y is equal to 3 to the x over, let's do one of the inverse trig functions because people hate those. Let's do sine inverse sine. So I'm going to be doing the quotient rule. I'm going to say the rhyme as I do the quotient rule. This time I might not write low d high minus high d low over low low, because that's the rhyme, and hopefully you've said it a bunch of times throughout this video. Don't feel that you are too weird if you're watching a video and you're just saying low d high minus high d low over low low like a crazy person. So let's do this. Low, low, just rewriting low. Then d high, remember that this is not the power rule, this is the a to the x rule. The derivative of a to the x, when x is the exponent as opposed to the base, is a to the x ln a. So in this case, low d high would be 3 to the x times ln 3. 3 to the x times ln 3. Low d high minus high, so we're just going to rewrite 3 to the x now. Not too bad. I like the part when I don't have to take a derivative. So it's 3 to the x. And then finally, you do need to memorize your derivatives. The derivative of inverse sine is this weird guy, 1 over the square root of 1 minus x squared. Again, that's just a derivative that I memorized that my students forget, and then they memorize it again, and they forget, and they memorize it again, but hopefully you'll know it eventually. Low d high minus high d low. And then finally, the easiest part, but a part that sometimes students miss just because they're not being super careful, remember to derive by low low. So that's it. Low d high minus high d low over low low. A nice little quotient rule example. So for my next two examples, what I want you to see is that you actually only employ the product rule and the quotient rule when you have x's in both parts of the derivative. So let me erase this real quick. Let me erase this guy. So don't forget the derivatives that we took previously when we had just constants times functions. So when you have something like y is equal to 8 times, let's take, I don't know, secant x. So this is a product. It's mentioned, it's separated by a dot. It's 8 times secant x. But what I would encourage you to do is not to do the product rule. I only do the product rule when both things of the product have x's. So in our previous example, it was ln x and square root of x. They both have x's. In this case, the 8 doesn't have an x, but the secant x does. So in this case, I'm not doing the product rule. I'm just doing the constant rule. So what I'm going to be doing is, because the derivative of a function times a constant is just that constant times the derivative of secant x. So it's going to be secant x tan x. That's all it is. No need to do the product rule. If you want to do the product rule, you'll see why you get the right thing, but it's just a little bit longer. Let's just try to do the product rule on this. So the product rule would be keep the first one the same, because you can keep the first one the same as long as you take the derivative of the second one. So that's going to be secant x tan x. Just put an x there. So again, anytime you're doing the product rule, first, derivative of the second. So it looks like now we need to keep the second one the same because we took the derivative of that one in the first part. So secant x. And then what's the derivative of 8? The derivative of 8 is 0 because it's a constant. So notice that this will go away and you'll end up with the top thing. So if you do the product rule in these questions, you're just going to be wasting time and it's going to get ugly. So again, I highly recommend that if it's just 8 times a number, or 8 times a function, a constant times a function, don't do the product rule because that constant doesn't include x. The best time to do a product rule is when you have a function of x times a function of x. Same thing with the quotient rule, and this is where it comes up even more evident that it's definitely better to avoid the quotient rule when you have a number in x. So let's see this. So for example, let's say I have the function 6 over x to the 5th. This could be the quotient rule, so I'm going to take the quotient rule, but it's going to get a little bit nasty. So I'm going to say the rule, it's low, which is x to the 5th. D high, and the derivative of high is 0 because the derivative of 6 is 0. So it's going to be low, d high, minus high, that's just writing 6. D low, this is the power rule time. So what's the derivative of x to the 5th? You bring the power to the front. So it's 5x, and then you subtract 1, so it's 5x to the 4th. Low d high minus high d low over low low, x to the 5th squared. So notice that even after I take the derivative, if I really wanted to simplify this bad boy, it would take so much effort. This goes away, that's fortunate. But it looks like we have minus 30x to the 4th, and then you're going to have to know some exponent rules. Just keep in mind that the rule a to the b to the c is multiplication of the exponent. So this is not x to the 7th, this is x to the 10th. And then finally, I would have to do another step. How do these cancel out? Well, if there's 4 x's on the top, 10 x's on the bottom, if you started crossing out x's like this, you would end up with 6 x's on the bottom. So it's going to be negative 30 x to the 6. But again, I would highly encourage you not to approach this problem this way, even if we're learning the quotient rule in this video. Sometimes it's not good to take the derivative of every single quotient you see, because this quotient involved the numerator where the numerator didn't have an x. Because the power rule is so much easier to use, quotient rule has this very, very long rhyme, but the power rule is just drop the exponent, subtract 1. It's so much easier, as we did in that power rule video, to change this to be 6 to the x to the negative 5. So that when we take this, remember that this is what negative exponents mean. If you have something divided by x to the 5th, that means that we have x to the negative 5th. Notice how easy it is to go from this to this answer right here. Because if you take the derivative with the power rule, you just drop the power to the front, so you have negative 30 x to the negative 6, because you subtract 1 from the exponent. Negative 5 minus 1, of course, is negative 6. And then notice that this immediately becomes this, because again, we're using those negative exponent rules. And you'll see that this is a lot easier than all of this madness right here. So again, while learning the product rule and the quotient rule is certainly very exciting, control yourself, restrain yourself. Don't do it for every single product and quotient you see. Do it only when you have x's both in the numerator and the denominator. But I did promise 10 questions, so let's do 4 more questions, I believe. So let's erase this. Let's do some more complicated stuff, or stuff where people might mess up. So let's erase, 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 erase. So in this case, what I'm going to do is I'm going to do this derivative right here. What have we not done? Let's do 2e to the x times cosine x. So this one is definitely going to be one where I do the product rule, because I have 2 things with x's. Unlike the previous example when I had 8 times secant x, I believe, that had just 1 thing with x. In this case, I have a to the x and cosine x. But this is one of the derivatives that people have trouble with. Not trouble, but they're not super careful. And it's because of this culprit right here, this little guy, this 2. What happens is you need to incorporate the 2, you need to distribute the 2 to both sides of the product rule. And so what I'm going to do is, I don't think of this question as e to the x times cosine x. If I'm doing my little underline business, what I'm thinking about is the first function is 2e to the x. I'm attaching this 2 to the e to the x because the e to the x is so lonely, he needs a friend. I'm going to think of this as the first thing, and I'm going to think of this as the second thing. If I do this, then I'm more likely to remember to distribute the 2 to both sides of the product rule. So let's see that in action. So what I'm going to do is I'm going to first keep this one the same, so it's 2e to the x. Then I'm going to take the derivative of cosine. The derivative of cosine is minus sign, so be careful with your memorization. So this was first derivative of the second. And then because we took the derivative, we kept this one the same, what we need to do is we need to take the derivative of this first one, but it's kind of weird because the derivative of e to the x is itself. So right here, we're going to write 2e to the x again, but just keep in mind that this is a derivative. So it's first derivative of the second plus the derivative of the first times keep the second the same. So it's going to be cosine x. But notice I have 2's in both sides of the product rule, and how that was possible is I just absorbed the 2, I attached the 2 to the e to the x when I saw this as first times the second. So just be careful, this 2 needs to be with both of them. And that's basically it. So 2e to the x, negative sine of x, plus 2e to the x times cosine of x. And that's where people mess up, but hopefully you can see that if you just treat this as 2e to the x times cosine of x, these are your 2 things in the product, it's not going to be too bad. So let's see another example of this, and then we'll have 2 hard examples at the very end of this video. So let's erase this guy. Erase, 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 erase. So let's do another one with a similar sort of thing. Let's do minus tangent. Actually, let's change it to cotangent x to make it crazy. And then let's multiply by x squared plus 3x. So it looks like, again, we have another product rule on our hands. We have this thing that has an x in it. But keep in mind that what we should do is we should think of this as one single thing, and notice that the negative is going to be attached. I don't want to mess up constants, so I'm going to attach constants always to the first thing, and then once I do that, it will be easier to remember to distribute to both, because I just follow the product rule examples and the product rule sort of process. So let's do that here. So let's first keep this one the same. Again, you can keep each one the same as long as you switch it in the second half of the product rule. So for this one, I'm going to keep this one the same now. So it's minus cotangent x. Then it's going to be times the derivative of this guy right here. And because this guy is a parentheses, when I do the product rule, I'm going to use parentheses as well, because I always want to be careful with parentheses. So I'm going to write times 2x plus 3. First times derivative of the second. If I didn't have these parentheses, technically it would be wrong, because this minus cotangent x needs to also multiply this 3. So just be careful with parentheses. If you ever do first derivative of the second and derivative of the second has two things, just wrap it all around in parentheses. So first derivative of the second. So now what we're going to do is the second half of the product rule. So it's going to be first derivative of the second plus, because the product rule is always split up by a plus. And then we're going to take the derivative of this one, because we kept that one the same in the first half of the product rule. So what's the derivative of cotangent x? Well, that's going to be minus, because there's a minus here. But then there'll be another minus, because the derivative of cotangent naturally has minus. It's actually minus cosecant squared. So it's minus cosecant squared x. And then finally, we're going to keep the same. Please forgive me that I ran out of room here. My friend Decidui is blocking me, but I'm going to write the keep the same at the very end here. So again, it's keep the same, derivative, keep the same. Notice I have the negative for both parts, because I'm attaching the negative to this function. Let me try to simplify this, of course. Negative times negative is positive, so let's do that real quick, and then we'll be good to go. So again, this was keep the same, derivative in parentheses, minus minus is plus, and this was a derivative, and then now we're keeping the same. Even my keep the same, I'm putting in parentheses, because again, anytime when you have this process, you want to keep these in parentheses when there are sums, because you want to be technically correct, because being correct is probably better than being wrong. So hopefully all this makes sense. Let's challenge ourselves with two more questions at the very end here, number 9 and number 10. So I'm going to erase this again. Erase, erase, erase. Erase, erase, erase. So let's see here. What do we want to end with? Let's end with, this is number 9. Let's do, what should we do? What should we do? So many options, so little time. So I don't think we've done a tangent to the -1. So let's do that. And then what we're going to do is we're going to multiply that by, let's take x squared plus 3. And then we're going to have just so many options. Let's have ln of x. Let's bring back ln of x. So we have this guy right here. And why not we attach this too, just to make things a little bit more interesting. So here, hopefully you see we're going to be using both rules here, because the second, it happens to be a quotient, but there's also a product. So just think in your mind right now, is this a product rule question or is this a quotient rule question? Well, what I'm going to argue is that it's a product rule question, because you have this thing right here times this thing right here. So the first rule I want to start off with is the product rule, but when I take the derivative of the second thing happens to be a quotient. So I'm going to be doing the quotient rule within the product rule. So this is going to get a little bit confusing, but let's see this in action. Probably should write it a little bit smaller here. So y prime. First thing to do is let's take the derivative of this thing right here. It's not going to be too bad, but keep in mind that for the first thing, I'm treating this as 2 inverse tan. So again, here's the first thing. Maybe we can underline it a little bit weirdly. And here's the second thing. So it's going to be derivative of the first, keep the second the same, plus keep the first one the same times the derivative of the second. So let's see that in action. So it's going to be derivative of this one. This is memorization. 2 times 1 over 1 plus x squared. So I took the derivative. So the product rule dictates that I keep this one the same. I'm not going to complain, because keeping the same just means rewriting. So it's going to be times x squared. just ln of x. I can't even rewrite. Ln x over x squared plus 3. So it's going to be first, derivative of the first, keep the same. Then what we're going to do is this plus is the plus that separates the product rule. Again, this is a product rule example. So what's the next thing to write? We're just going to write this guy right here. 2 tan negative 1 to the x, because that was derivative of the first. Derivative of the first, I don't know what I'm saying anymore. Derivative of the first, keep the second one the same, keep the first one the same, and now take the derivative. We finally look at the derivative. It happens to be a quotient. That's okay. Just we're going to multiply by a quotient rule within this question. So what's the quotient rule, of course? Well, it's low, so it's going to be x squared plus 3. X squared plus 3. Notice that I'm putting it in parentheses because low happens to have two things, so I want to wrap it all in parentheses. Times derivative of high. That's going to be 1 over x, because that's the derivative of ln of x. So it's low d high minus high, just writing ln x again. We'll put it in parentheses. And then finally, what's the derivative of d low? So it's low d high minus high d low. Using the power rule, the derivative of x squared plus 3 is just 2x. So let me try to squeeze that in here. And then finally, it's over low, which is x squared plus 3 squared. So a pretty complicated question. You will sometimes have quotient rule within product rule or product rule within quotient rule, but just see what is the larger thing, and if this one of the larger parts of the thing is the other one, like for example, we have a larger product rule, but the second thing of the product rule is a quotient rule, just apply the rules in the logical order. So again, it's derivative of the first, that was pretty normal, that was just memorization, keep the same, that was just rewriting, plus keep the same, and then it just so happens to be that our second thing is a quotient, so we're going to take the derivative using quotient rule of the second thing. So hopefully that makes sense. Sometimes we're going to be mixing rules within rules. Let's do that one more time. Let's get going. Let's see how much we know. I believe in us. Product rule, quotient rule. How fun, how fun. So last one. So it's going to be y equals, let's do 9 on the bottom. What else should we have here? Let's just do cosine x. And then finally on the top here, I'm going to write 3. Let's not do 3, I think we did 3 last time. So we're going to do 5dx times x to the 5th. So try to do this question, pause the video. There's only one last one, this is the last one. Let's try to end up on a bang. Pause the video, in 3 seconds I will try to do the question for you or try to verify that you are the best derivative person in the world. You did get it correct. So just pause the video. 3, 2, 1, let's get going. So hopefully you see that, again, we have product rule and quotient rule in the same question because we have the product rule on the top, but we have a quotient, an entirely big fraction. That's different than the other question because notice that the essence of the question, the spirit of the question, the soul of the question, this is going to be a quotient where the numerator happens to be the product. So what we're going to do is, because the essence of the question, because y itself is a quotient, we're going to be doing quotient rules. So we're going to do low d high minus high d low over low low. But as we do d high, it's going to require the product rule. So it's going to be low like normal, d high, it happens to have product rule. So we're just going to do product rule with d high, maybe careful with parentheses, minus high d low over low low. So let's see that in action. Let's write over here because it's going to be a very long answer. Let's put a really long fraction bar to anticipate what's going to happen. So it's low, that's pretty easy, just rewrite. And then d high, so here again, d high is a product itself, so we just have to do the product rule. If you come up with something and you just look at it and you're like, oh, this requires something, we have to do it. So this is the product rule, so it's going to be first times derivative of the second, that's the power rule. 5x fourth being the derivative of x to the 5th, because you bring down the power subtracting 1. Then we're going to write plus, because this is only the first half of the product rule within d high, low d high. Remember that this is not the power rule, this is the a to the x rule, so it's going to be 5 to the x times ln 5 times x to the 5th. Wow, look at my fraction bar, it wasn't even long enough, but hopefully you can see, I'm going to erase the fraction bar now, because this is an insanely long answer, but it's low d high, and again, all of this is d high. Notice how careful I was with parentheses. Hopefully you understand that this is still part of the fraction. Low d high minus high. This part is not bad. It's going to be just rewriting this. So this is again all the fraction just listed out, the numerator of the fraction listed out in 2 rows because this question is such a monstrosity, but it's low d high minus high, and then what's the derivative of low? That's going to be not too bad, minus 9 times sine x, because the derivative of cosine is minus sine. So this is the answer, low d high minus high d low. Of course we need to divide by low. Let's actually add the fraction bar. So this is a fraction bar. And keep in mind that I don't want to just write cosine squared x because the 9 is also in the denominator, so it's going to be 9 cosine x squared. And I'm not going to simplify this because this is so complicated, but again, hopefully you see how to do these questions even in the most complicated examples. You look at this, it's a quotient, so you're like, oh, I'm going to have to do the quotient rule. But you see that the numerator is a product, so then as we do d high, we are going to be doing the product rule. Low, rewrite, d high, so all this was the product rule of the numerator. First, derivative of the second plus derivative of the first, keep the second, and then the rest was pretty easy. Minus high, just rewriting the numerator times d low, memorize the derivative of the denominator over low. And that's it. So hopefully this video was a nice, gentle introduction of the product rule and the quotient rule. Just like normal, we have another video, a Girls Teach Calculus video on the product rule and the quotient rule if you want more examples. One of my former students goes over more examples where we mix up the rules. We do some basic ones, we do some harder ones. We try to talk about all the derivatives so that you get better and better at memorizing the derivatives. So check out that video, that's going to be in the description below. In our next video, in our next lesson, what we're going to be talking about is the most important rule of all. That's going to be the chain rule. So be on the lookout for that. Hopefully I'll see you there. Thanks again for watching. Like and subscribe if this was a useful video for you. And I hope to see you in that chain rule video. Thanks again for watching.